Hi everybody. Today we're going to be thinking about different functions that we can integrate. And so we're thinking about, well, we had the chain rule for differentiation, which was if we've got some function which was f of g of x, so we had an inside function. Then under the derivative, so if this was h of x, then the derivative h dash of x was f dash of g of x, so we differentiated the outside function, then we multiplied by the derivative of the inside. Now, an example of that is where we had a linear function inside, so a polynomial, but only where the highest power was 1. So it might be something like ax plus b to the power of n. And so if that was h of x, then the derivative h dash of x was, we multiplied down that n, and then we took one and we multiplied by the derivative of the inside, which is a. So to reverse this, we just do the opposite. So the reverse is add 1 to the power, and then divide by new power, which is what we saw last time. But then there's this added bit of dividing by the derivative of the inside. So in this case, what this means is that provided that there's a linear argument, which just means that there's a linear function, so a polynomial where the highest power is 1, as our inside function, we can integrate. But we can't do anything more than that. So we call this simple anti-chain rule, so linear argument only. So if we consider some functions, so we've got a type of function, so this is our power, polynomial function, more or less. And so then, as we were saying before, then it's add 1 to the power, divide by the new power, and also out the front we're going to add in this factor of 1 on a. So we're dividing by the derivative of the inside. And that should be n plus 1 down there. Okay, how about an exponential? Well, it's the same idea. Now, the integral of an exponential is just the exponential, but in this case, we need to divide by the derivative of the power. So we'll just have this 1 on a factor out the front again. What about if it's trig? Well, same idea. The integral of sine is negative cos, and we're going to keep the same thing, but we're also going to divide by a out the front. So it's going to be negative 1 on a cos, and then the cos is sine ax plus b, but it's also going to be 1 on a out the front again. So we're dividing every time by the derivative of the inside. And then finally, if it's log, or I suppose we're actually integrating a reciprocal function, so in this case, it'll be ln of the modulus of ax plus b, and we'll be dividing by 1 on a, or we'll be dividing by a out the front. So in every case, provided that there's a linear argument, we will be able to divide by the derivative of the inside out the front. But if there was a quadratic in here, or if it was a cubic or anything else, even if it was cos or sine, we would not be able to follow this process. We would not be able to integrate. Okay, so we're going to just do some integration, find some indefinite integrals. So integral of 7x take 2 to the power of 4 dx. We saw that the rule was, well, we add 1 to the power, we divide by the new power, and we multiply by 1 on 7 out the front. So it'll be 7x take 2 to the power of 5 all over 35. And I should have my plus c. Okay, so plus c as well. Okay, all right, how about this one? Well, looks a bit harder, but we know that we can write this as a power or a linear argument to a power just so the power is negative. So we don't worry about the constant, that just sits there. It'll just be part of our integral. So then I have to first of all add 1 to the power. So it'll give me minus 2, divide by the new power, so divide by minus 2. And also we need this factor of 1 on 2 out the front as well. So then if I go through and simplify that, well, those give me minus 4, so it'll be 5 on minus 4, 2x plus 3 to the power of minus 2, and then all out the front of a minus over 4, 2x plus 3 squared. Okay, alright, and again, I forgot my plus c. You should be yelling, I hope you're yelling at your computer screen by now, telling me to put a plus c in. Okay, alright, now we're going to integrate again. So, here we've got an exponential, so it'll just be the exponential, the constant will also be there, so the integral will be 3 e to the 4x plus 1, but I need to add in this idea of dividing by 4. So it'll be 3 on 4, and then it'll be take e to the negative 2x, and I divide by this minus 2, and I included a plus c. Good, you didn't have to yell at your computer screen that time. So it's 3 e to the 4x plus 1 over 3/4, then it'll be plus e to the negative 2x on 2 plus c. Now you might be wondering, do you write it as a fraction out the front? Do you put the whole function over it? Doesn't matter, okay? It's the same thing, so it really doesn't matter. Okay, how about this one? Well, we've got a quadratic argument, and I said we couldn't do that. So what do we have to do? We have to expand. So let's just make a real key point about this. Cannot use rules on this one. So expand. And you may be a little bit sad about the fact that we have to expand. Well, I have to do it, but I'm a bit sad about the fact that I have to expand because it's a bit painful. But we know how to do a perfect square, so it's x to the power of 4 plus 2 by x squared times 3 plus 3 squared. Now, this we don't put plus c yet because this is still a function that we're integrating. So it'll be the integral of x to the 4 plus 6x squared plus 9, and then if I look to integrate that, that'll give me a fifth x to the 5, add 1 to the power, divide by the new power, plus 6 on 3x cubed, plus 9x plus c. Okay, which is a fifth x to the 5 plus 2x cubed plus 9x plus c, and that's my final answer. Okay, alright, so fifth one. Got a sign. Now, we've got a constant out the front of the sign, but that doesn't matter. It will just sit there. So we're going to get 2. Now, integral of sine is negative cos. So it'll be 2 times negative cos. Make sure you put a multiplication sign in there. If you don't put it, it looks like 2 take cos x. And so that'll be marked straight away wrong. So it's cos of 3x. Divide by that derivative of the inside function. Now, integral of cos is sine, so it'll be plus sine 4x plus pi. What's the derivative of 4x plus pi? Well, it's just 4, so it'll be 1 on 4 out the front. So we're going to get negative 2/3 cos 3x plus 1/4 sine 4x plus pi plus c. Okay, I forgot that one again, so I hope you're yelling at your computer screen. Okay, now how would we do this one? Well, with this one, we need to be able to write it as some linear function to a power, but we can do that. There should just be the integral of 1 take 3x to the power of minus a half. Okay, alright, so we add 1 to the power, so it'll be 1 take 3x, adding 1 to the power gives us a half. And then we divide by the derivative of the inside, which is dividing by minus 3. So I get negative 1 on 3, and I'm going to have a plus there. I didn't forget at that time. You didn't have to yell at your computer screen. It's all good. I've got it under control. So negative 1/3, 1 take 3x to the power of a half plus c. So if I just simplify that down a bit, that's negative 1 take 3x, or root 1 take 3x over 3 plus c. And so then I'm done. That's that one done. So we added 1 to the power. Hang on. I needed to divide by the new power. So it's easy to forget the little things. So I hope you were yelling at your computer screen. So that will become, so we'll be dividing by a half, which is the same as multiplying by 2. So I'm going to get, I'll just rewrite it here, negative 2/3 root 1 take 3x plus c. Okay, alright. Now, show that, okay, we need to find this integral, but we've got to do some different work first. So we've got to show that, so we'll just take the left-hand side equals 5 on 2x plus 3 plus 2 on x take 2. So we need to show that that's equal to this function here. So in this case, this denominator comes up the top there, that denominator comes up the top there, and both multiply to form the new denominator. So it's all over 2x plus 3, x take 2. So it's 5 outside of x take 2 plus 2 times by 2x plus 3. Now this is a show that, so we need to show enough working. So in this line, I would now expand the top line. So 5x take 10 plus 4x plus 6. So I've expanded the top line. Haven't simplified it yet. So you don't want to expand and simplify in the same step. You want to leave a step between that. I could also expand the bottom line. So that's 2x squared take 4x plus 3x take 6. Again, don't simplify just yet. Okay, now the top line becomes 5x plus 4x, which is 9x, minus 10 plus 6, which is minus 4, all over 2x squared, take x, take 6. Then I look back, have I got what I wanted? Yes, I do. Okay, so one step to expand, another step to actually simplify before I get to my final answer, so I satisfy the show that. Okay. Now, they would never ask you, so we could just say that equals the right-hand side, they would never ask you to integrate a function in the same question, and these would be two different parts of the same question, but it still applies, if they didn't actually want you to use what we'd already done. So we need to find the integral of this, so you can pretty much guess that the first step would have to be something to do with this. So we can make that substitution. Now, we don't have a rule to be able to integrate when one thing is divided by another thing. So, when they're both functions of x, but we do know how to do these. So we can write it as the integral of 5 on 2x plus 3 dx plus the integral of 2 on x take 2. So we can go term by term. And then, when we're looking to integrate, we can go, well, it's 5 by 2x. So it's the integral of 5 by 2x plus 3 to the power of minus 1 dx plus the integral of 2 by x take 2 to the power of minus 1 dx. Okay, now we're ready to integrate. So this is the power of negative 1. So it's an ln. So it's going to be, well, I'll start by doing ln modulus 2x plus 3. This 5 is going to stay out the front, but I'm also going to have to divide by the derivative of the inside, which is 2. That's going to be plus 2 ln modulus x take 2 divided by the derivative of this inside, which is just 1. So it'll be plus 1. And then it'll be plus c on the end of all of that. Now, we then need to work out what this c is, because we're told that when x equals 3, f of 3 is equal to ln of 118098, and we're also told that c is equal to ln of k. So, I can say that f of 3 is equal to 5 on 2 ln. Now, 2 times 3 is 6, plus 3 is 9, so it's ln of modulus of 9, which is just 9, plus 2 ln of 3 take 2, which is 1, modulus of 1 is just 1, and then it's plus ln k, because c is ln k. So, ln of 1 is 0, so I'm just going to ln of 9 to the power of 5 on 2 plus 0 plus ln k. Bringing this 5 on 2 up is going to help me bring these two ln's together. So I've got ln of 9 to the power of 5 on 2 plus ln k. So it'll be ln of 9 to the power of 5 on 2 times k. And that is equal to ln of 118098. And then I can say that 9 to the power of 5 on 2 times k is 118098. And then k is just going to be 118098 divided by 9 to the power of 5 on 2. So k is 486. I'll just double check that on my calculator. Yep, so k is 486. And so the final function is f of x is equal to 5 ln of 2x plus 3, modulus of 2x plus 3, plus 2 ln of modulus of x take 2 plus ln of 486. We could seek to simplify in slightly different ways, but that's fine. We'll just leave it like that. And that's the end of what we're doing.